Hey, peace guys, hope everybody's well. So I wanted to make a video today because I've seen quite a lot of globe believers posting this equator water trick that allegedly proves that the Coriolis effect is real and that we live on a globe because of that. Now what the trick is they take a basin of water with a plug hole in it from the southern side of the equator and the northern side of the equator, and they do it on the equator line as well, and the water goes a different way down the plug hole each time. Now this is just a trick that depends on how you pour the water into the basin. So first we're going to have a look at the trick that's being performed itself, and then we're going to have a look at a demonstration in a sink that doesn't move, and then we'll have a look at the trick again so that we can see what's going on.
This is in the middle. So if we are in the middle, how should the water go?
Straight down.
It's straight down, exactly. Look at the surface. Ready? Everybody ready? Sure. Yeah, so look at the surface. Uno, dos, tres. Here we have some leaves. And as you can see, there is not a very big rotation, any vortex, and it is just going straight. So all over the equator, all over the line, is the same. But now guys, let me show you just a very simple simulation of this effect. And we are going to the south, this way. Come around guys. This is the south. Do you remember the direction?
Clockwise.
Yes, clockwise, yeah. Cyclones, for example, if you go to Australia, it should be the same. To the right or clockwise. Yes, in the south. But now, let's move to the north. And this is the north. Well, so here should be the opposite. Let's see. Ready? 1, 2, and 3. Okay, guys, so to the left. Now you feel like home. So different directions in each side. Remember the natural effect produced by the rotation of the Earth. But with a simple simulation, we could understand how it works. Okay? Well, it was the first.
Awesome.
So as the keen observer might have already noticed, we don't see the lady pouring the water into the basin while she's on the equator line. So it could have easily been sat there for 10 minutes and have no vortex in the water, which is why it falls straight through the plug hole. And then when she's on the southern side and the northern side of the equator line, she pours the water into different sides of the plug hole, creating a vortex on different sides of the basin. So now let's just have a look at a demonstration in a sink that doesn't move to see what effects we get from doing that.
So this time I'm going to angle slightly this way, still pouring in the middle. Heavy water. Alright. About a 5-degree angle, I would say. And I would anticipate that would make a counterclockwise rotation. So let me just add a few pepper flakes. You can see the rotations there already. Obviously it's going to go counterclockwise. Take this out vertically. Counterclockwise. Pushing in that direction. And let's add our contrast material, which is some red pepper flakes. And now we see we still have a little bit of stillness over here, but we have a larger vortex which has taken over the whole thing. We could let this settle down for a while, I think. You can see there's actually a counter-rotating vortex over here, but the larger vortex is over here. And of course, if I pull the plug out now, it's going to give me the clockwise spiral down, which is what you'd expect. So that's the trick. You just need to have a sufficient tilt in the direction that you want it to go, about that much or about that much, which is exactly what we see in the videos. So I'm going to pull this out now and show the clockwise vortex going down the drain. There we go. Spinning away clockwise.
Now that we've seen how the effect can be achieved in a static basin, let's go back and have a look at the lady performing it on the equator, so you can see for yourself beyond any reasonable doubt that that's what she's doing. It's simply a trick. If you want to see some more Flat Earth information or join our Flat Earth groups, check the links in the description below this video. Peace on the plane, guys.
This is in the middle. So if we are in the middle, how should the water go?
Straight down.
It's straight down, exactly. Look at the surface. Ready? Everybody ready? Sure. Yeah, so look at the surface. 1, 2, 3. Here we have some leaves. And as you can see, there is not a very big rotation, any vortex, and it is just going straight. So all over the equator, all over the line, is the same. But now, guys, let me show you just a very simple simulation of this effect. And we are going to the south, this way. Come around, guys. This is the south. Do you remember the direction?
Clockwise.
Yes. Clockwise, yeah. Cyclones, for example, if you go to Australia, it's the same. To the right or clockwise. Yes, in the south. But now, let's move to the north. And this is the north. Well, so here should be the opposite. Let's see. Ready? 1, 2, and 3. Okay, guys, so to the left. Now you feel like home. So different directions in each side. Remember the natural effect produced by the rotation of the Earth. But with a simple simulation, we could understand how it works. Okay? Well, it was the first.
Awesome.